This is the video for probability part A, and if you would please put the learning target on your note sheet. I can find sample spaces and probabilities. So we're going to focus on finding sample spaces in this video. Our example problems will help us do that. And then also we're going to be looking at finding the probability of something actually taking place. So a lot of this vocabulary is most likely new to you, and if you would please pay attention carefully. Don't just rush through this part, but you do want to make sure that you understand each and every vocabulary term. And these vocabulary terms will also be posted in the classroom. A possible result of an experiment is an outcome. So what is it that could happen when we do an experiment? For instance, if you're flipping a coin, what are the two outcomes that you could obtain when you're flipping a coin? If you're spinning a spinner, what are the outcomes of spinning that spinner if you're playing a game? All right, the next vocabulary. An event is an outcome or a collection of outcomes, such as rolling an odd number. So if you have a die or dice, what's the possibility or probability that the event, rolling an odd number, will take place? And we also have the set of all possible outcomes is called a sample space. And you will probably notice that oftentimes sample spaces are written within brackets, the curvy brackets like that. The probability of an event is the measure of the likelihood, chance, likelihood or chance that the event will occur. So again, if I ask you what's the probability that it's going to rain today, what's the likelihood or chance that that event, rain, will occur? The odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. One last thing I would like to add before we look at our first example is when we write probabilities, probabilities are often written in a decimal form. So you may see there's a 0.5 chance that something will happen, or you could see it written as a percentage, 50% chance of something happening, or you might see it written as a fraction. Okay, when we have fractions, we want to reduce those fractions to its lowest term. So let's just say we're talking about the likelihood of it raining. Well, there could be a 0.5 chance that it's going to rain, a 50% chance that it's going to rain, or a 1 in 2 chance that it's going to rain. So just be familiar with the way that probability can be written in the different forms. All right, for our first example, we want to find a sample space. So we need to write in all the different ways that this particular experiment could take place. What are the outcomes? What could happen? And we're going to toss 3 coins, or we're going to toss the same coin 3 different times. How many possible outcomes are there in the sample space? And it's asking us to list the possible outcomes. So for coin number 1, if I have the first coin, what are the possible outcomes of flipping that coin? I tossed it in the air. Well, what could land up? The heads could land up, or the tails could land up, right, facing up. So if I do the second coin, coin number 2, if I got heads the first time, couldn't I also get heads the second time? Or I could get tails. If I got tails the first time, couldn't I get heads the second time with the second coin? Or I could get tails. So you can see my little tree that I'm building here is kind of going down a path. I had heads the first time, I got heads the second time. That's a possible set of outcomes. Now I also have to set up a situation where I'm tossing the third coin, and if I got heads the first 2 times, I still could get heads a third time. Not a very high chance of that happening, but it's possible. If I got heads and then tails, I could get heads a third time. So you can see what's going on here is each time there is a toss, there's a possibility of getting heads or tails. So when I put this information into my curly brackets there, I'm looking at the 3 different things that could happen the 3 times that I toss a coin. So I could have 3 coins come up with heads at the top. I could also have this situation take place where I get heads the first 2 times but tails the second time. Sorry, heads the first 2 times but tails the third time. And I could get heads, tails, heads. That's this path here. Or I could get heads, tails, heads. So you don't have to draw those circles around there, but I just want you to see where I'm getting this information from. Okay, so we could have had 3 coins come up with heads, all heads like this, or this situation, this situation, this situation. Now I've only started with the point where I had heads the first time. What if I got tails the first time? Well, there's these other 4 paths, and I'm just going to write them in. All right, so I have those written in, and there are a total of 8 different possibilities. So the total number of possibilities or outcomes is 8. And here's our sample space. This sample space lists all 8 of those possibilities. Now, in the practice problem that you're going to do on your own, there is a spinner. Okay, so imagine yourself playing some kind of board game, and you are going to spin the spinner each time it is your turn. 1, 2, 3, 4, 5. And it says right here, a spinner has 5 congruent spaces. So there's an equal amount of chance that you're going to spin one of those numbers. And the numbers are 1 through 5. You spin the spinner and you toss a coin. Okay, so just like I did above, I was using heads or tails from the coin. Those are the outcomes. And there are 5 outcomes for spinning this spinner. Okay, so there are 5 outcomes from that and 2 outcomes of tossing a coin. So you need to come up with how many possible outcomes are going to take place, and then also list the possible outcomes. So I need you to list in a sample space, like in those brackets there, how, like, all the different options that could happen. So think of yourself spinning a spinner and then tossing a coin. What could possibly happen? Please list those on your page. On the back side of your notes, we have example 2. It says find a theoretical probability. Theoretical probability is based on numbers. So based on numbers or based on fair numbers, let's just say it that way, because it's the number of times something should happen if everything is fair. So looking at the numbers that we have on this chart, we have some, well, in a bag, we have numbered balls, and some of the balls are red, some are blue, some are yellow. The table shows the number of the numbers of each type of ball. A ball is selected at random. What's the probability that the ball selected is odd and yellow? Well, we have some odd numbers here, and if we add these all up, we can see that we have 26 total odd numbered balls and 24, if I add these up, even numbered balls. So the total number of balls in this bag is 50, and it's looking like there are 17 red, 15 blue, and 18 yellow. So I can figure out the total number of each one, and then I can figure out how many are odd and yellow. So from the, like, if I wasn't looking in the bag and I just randomly pulled a numbered ball out of the bag, how many, or what's the chance that I'm going to get an odd one and it's going to be yellow? So it looks like to me, here's the cross between odd and yellow, and I end up with 8 of the balls are odd and yellow out of 50. However, I want to make sure I reduce my fraction to its lowest term. So there's a 4 out of 25 chance that I'm going to select an odd ball that is yellow. And I just want to quickly mention that experimental probability is the keeping track of actual experiments. So experimental probability does not necessarily match up with theoretical probability. So theoretically, each time I draw a number out of the bag, it should be yellow and odd every 4 times out of every 25 times I pull a number. However, experimental probability is actually doing an experiment and recording the trials, or recording each time you pull a number out, and then recording it and verifying, you know, how often did I get blue even, or how many times did I get red odd. So we're going to practice doing experimental probability and compare it to theoretical probability when we are in class. The on your own problems down here, I would like you to practice using this idea that we just were looking at. However, you're going to be looking at choosing a ball that is even and red. Remember, there are 50 balls in the bag. Make sure that you reduce. Each time you get a fraction, I want you to make sure you reduce to your lowest terms. You also want to take a look at this chart, and I would like you to find not odd and blue. So make sure you pay attention to that. That could be a little bit tricky. What is the probability that a randomly chosen ball is odd? Doesn't necessarily mean it's a different color, just if it's odd. Okay, don't forget to reduce each time. If you have questions about anything in this video, I'll be happy to answer that in class tomorrow.